Hello everyone, this is Revati working as an assistant professor in the Department of Information Technology from SNS College of Technology. Welcome to this lecture on TCP header in computer networks. In today's session, we are going to understand why TCP is needed and what information is stored in the TCP header and how TCP ensures reliable communication between two systems, that means client and server. This concept is part of transport layer in the OSI model and it plays a major role in ensuring that data is delivered correctly, completely and in the right order which was sent by the user. This is the today's agenda. Let's we see the topics one by one. In my previous video, we have seen about what are the services provided by the transport layer and what is meant by user datagram protocol. That is nothing but connectionless and unreliable protocol. In my today's lecture series, we are going to see about transmission control protocol, which is having connection oriented and it is also reliable protocol because it ensures that the all the data are received by the receiver. Let's we see the design thinking phases one by one. First, understand the need of TCP. Let us begin with a simple real world example. Imagine you are sending an important document through courier service. You expect the courier company to deliver it safely without losing any pages, right? And it is the in the correct order. Now think about communication between computers. What will happen? When we send data through the internet, the data is divided into smaller pieces called segments. These segments travel through different network paths. So the challenge is, how do we ensure data is not lost? How do we ensure data arrives in correct order to the receiver? How does the receiver confirm that the data has been received? This is exactly the TCP is helps here. That means transmission control protocol. The next phase is nothing but define phase. Here we will see about what problem does TCP solve in our real world example. The TCP is a connection oriented protocol used in transport layer. Already I told that before sending data, TCP establishes a connection between sender and receiver. This is connection-oriented services. The main responsibility of TCP include reliable data transmission, error detection and correction, flow control, congestion control, and sequencing of data. To manage all these tasks, TCP uses a special structure called the TCP header. The TCP header contains important information that helps both system manage communication efficiently. The next phase is the key features, that means ideate phase of TCP. When data is sent using TCP, it is divided into segments. Each segment contains two parts. They are nothing but header and data. This diagrams will explore a different field which is available in the TCP header. Um, the main ports is having header and data. The TCP header carries control information that helps the receiver understand the segments. Some important features are supported by the TCP are sequencing, that is nothing but ensures data arrives in correct order. The next is acknowledgement, confirms the successful delivery of data to the receiver. Then next is flow control, prevents receiver overload. Then next is error detection. It identifies the corrupted data in order to retransmit the particular lost data. All these mechanisms together ensure reliable communication over the internet. Next phase is the prototyping phase. In this phase, we will understand the TCP header fields. It is having a source port and a destination port. Source port is nothing but the center IP address, and the destination port is nothing but the receiver IP address. For example, web applications, we are using the port number as 80 or 443. The next is the sequence number. It will define which order the receiver can send. That particular order the receiver can receive. The TCP actually numbers bytes, not segments. The next field is acknowledgement number. This field confirms that the receiver has successfully received data. These are the control flags which is used in the TCP header. That are common flags include SYN is nothing but synchronization. It is indicate the start conversation between the sender and receiver. The next field is ACK, that means acknowledgement, acknowledge received data. The next control field is FIN, it indicates the end of connection between the sender and receiver. The next field is RST, that means reset connection. And next is window size used for flow control. It tells the sender how much data the receiver can accept. The next is next field is checksum, used for error detection and correction. It ensures the data integrity. The next phase is the testing phase. It is quick concept check of TCP. Let us test your understanding. Suppose the receiver successfully receives data up to number 1000. What acknowledgement number will it send to back? The answer is 1001 because the TCP acknowledges the next expected byte. If any byte is missing, the receiver will request for retransmission to the sender. This mechanism ensures the reliable communication. Let's see the challenges faced by the TCP. Overhead and real-time unsustainability. These are the problems faced by the TCP. Next, we will see the quick summary of today's lecture series. TCP ensures reliable communication in network. Then the TCP header contains important control field. It will carry 6 flags. Then next is understanding the TCP header helps us to understand how the internet ensures reliable data transmission between the sender and receiver. Thank you for watching.